Welcome to Tungalona classes. In this session, we will discuss extent part of optical instrument. In the last class, we have seen that simple microscope, how simple microscope can works. Now, in this session, we will see compound microscope and what are types of telescope that we will see. Let us go compound microscope. The optical instrument which produces the enlarged image of very smaller object that we are calling compound microscope. I mean, the simple microscope is sometimes unable to obtain an enlarged image of smaller object. In that cases, we are using compound microscope. How it is? The device which produces an enlarged image of smaller object that we are calling compound microscope. In compound microscope, how to take magnification produced by these two lenses that we will see. Generally, compound microscope consists of two convex lenses of different focal length. One convex lens of smaller focal length that we are calling objective, and second convex lens of larger focal length that we are calling eyepiece. Both objective and eyepiece are placed along coaxially in a metallic tube that we will see how the construction looks like. Look at me. Compound microscope consists of two convex lenses. One convex lens of smaller focal length that we are calling objective. This we are calling objective of smaller focal length. Another convex lens of greater focal length that we are calling eyepiece. This we can call eyepiece. The both objective and eyepiece are placed along coaxially in a metallic tube, on a metallic tube. Look at me, how it is. Here, the both convex lenses having common focal length, common principal focus and principal optical center. Look at me, how this is. See here, both consist of a common optical center like this. Now consider the focal length of this objective I can represent by f0, and for this object eyepiece it is represented by ft. Now how it is working? Let us take a very smaller object just placed behind the principal focus. How this is? Look at me. This is nothing but a principal focus. I can call represent by what value? F value. So that just behind the principal focus, any one smaller object available. This smaller object of the height what? Object of the height AB. Very smaller object available. For this smaller object, of what distance from the optical center? Consider it is optical center, and this distance I can represent. This distance I can represent by what value? U0. For my convenience I will take. Read this now. Consider the ray of light incident from the object and get refracted through objective. How this is possible? Look at me. Consider, let us take one ray of light incident on the lens and get refract. After refraction, the ray of light can comes like this. Right around this. See here, how this is. The ray of light can passes. Comes like this. Now consider the one more ray of light that is passing through optical center and doesn't deviate it. How this is possible? Now let us consider one more ray of light that is passing and meeting at this point. Then what happens? Both the ray of light they can meet at this point. This point I can call B dash. This point I can call B dash. If we join this, then this represent what value? A dash. What is A dash? B dash? A dash, B dash represent intermediate of the object AB. Where the image can occur? From this optical center. Consider this is nothing but the image. This image I can represent by what value? V0. Then this image A dash B dash, it is act as a object for this lens. Object of the lens eyepiece. To this eyepiece, this image A dash B dash, it is act as an object. I mean, to this image, this eyepiece act as a magnifying glass. So that after incident from this ray of light can refract and passing through optical center. Right around this again. From this again ray of light can passing and it can get refracted like this. So here any one observer stands at this point. Any one observer stands. And observer see the refracted ray of light. How it is? When observers see the refracted ray of light, this ray of light can meeting and they can meet at some other point. Consider this is nothing but refracted ray. It can comes like this, meets here. One more ray of light, it comes like this, it can meet here. So that where the image can occur, exactly at this point image can occur. This point I can represent by A double dash and this point I can represent by B double dash. So where the image can occur, exactly image can occur at this point. This point represent by what value? D. List the distance of distant vision. Image can occur at this point. Now, how to take magnifying power of compound microscope? Simply, magnifying power of the compound microscope can be taken by taking magnifying power of objective and magnifying power of the eyepiece. Simply, magnifying power of this compound microscope is equal to magnifying power of the objective and magnifying power of the eyepiece. Just represent by what value? Question mark. I said that this eyepiece, it is act as a simple microscope to this image A dash B dash, so that the image can occur at this point. Now initially I can define what is magnifying power of the objective. This objective has how much focal length? This objective has this much focal length. I can represent by this focal length is equal to what value? F naught. Right around this. Then where object is available at this point. How to define and for this eyepiece what is focal length? That is represented by Fe. Initially I can define magnifying power of this objective. How to define magnifying power or linear magnification? Simply linear magnification is nothing but ratio of size of the image to size of the object. See here, how to define? That linear magnification is equal to what value? V naught divided by U naught. This V naught is taken to be positive according to convention and U naught is taken to be negative. So that I can represent by this value, what value? Minus U naught. Now I said that to this image A dash B dash, this one is act as image. I mean this one is act as simple microscope. For simple microscope already we know magnification. See here. Magnification of the simple microscope, how to represent? It is what value? 1 divided by what value? D divided by F. Already you know this. Magnifying power of this eyepiece can be represented by Fe and focal length can be represented by Fa. So that what can represent? Now linear magnification of the eyepiece can be represented by this equation. Similarly, linear magnification of the objective can be represented by this equation. Then what about above equation becomes? Look at how to represent this value then. Then M is equal to what value? M naught. M naught is equal to what value? Minus V naught divided by U naught into 1 plus D divided by Fe. But look at me. Actually this V naught is produced. V naught is produced, it is equal to total length of this tube. I mean total length of this tube is what? The total distance between two lenses, simply it is represented by L. And this image nearly equal to length of the tube. How to take here? The length of the tube nearly equal to image form. I mean image is nearly formed at the eyepiece, so that this L is nearly equal to what value? V naught. Similarly, this object is just placed behind the principal focus. So this principal focus shall I represent by F naught? That is principal focus of the objective lens. So that I can represent directly principal focus. Principal focus mean distance between pole and principal focus. You can call focal length. Represented by F naught. So that directly the U naught again nearly equal to what value? F naught. Again this equation can modify. How this equation can modify? This M is equal to what value? V naught. V naught can be represented by what value? L. U naught can be represented by F naught into bracket 1 plus D divided by what value? Fe. So this is magnification produced by compound microscope. And this is ray diagram. And what I am calling this? Magnification produced by compound microscope. After this, let us take one more optical instrument. Its name is nothing but telescope. See here. Shall I remove this? Now after this, we will see the one more concept. The concept I can call telescope. Look at it. Shall I take? After this we will see the one more concept, the last concept of this ray optics, that we are calling telescope. See here, the telescope or the optical instrument which used to see the image of the distant object, like image of the moons, image of the stars, and image of the distance object can be used by using a telescope. Simply, the optical instrument which are used to see the distance object, that we are calling telescope. Telescope mainly classified into two categories. One we are calling refracting telescope and second one is reflecting telescope. Look at me. Telescope classified into two categories. One we are calling refracting telescope. Refracting telescope. Refracting telescope. And second one is reflecting telescope. Reflecting telescope. See here, two types of telescopes are available: reflecting telescope and refracting telescope. Again, refracting telescope again classified into two categories. One we are calling astronomical telescope and second one is astronomical telescope and Cassegrain telescope. Look at me here. Two types of refracting telescopes are available. So one we are calling terrestrial telescope and second one is astronomical telescope. See here, how to take refracting telescope again classified into two categories. One we are calling astronomical telescope. Astronomical telescope. Astronomical telescope. And second one is terrestrial telescope. Terrestrial telescope. Terrestrial telescope. See here, generally refracting telescope consists of convergent lenses, convex lenses, and reflecting telescope consists. The reflecting telescope consists of converging mirrors. Refraction only takes place through lenses, reflection takes place in case of mirrors. So that refracting telescope consists of converging lenses and reflecting telescope consists of converging mirrors. See here, in detail we will see refracting telescope. For refracting telescope again two types as said. One we are calling astronomical telescope and terrestrial telescope. For our syllabus we have to see only astronomical telescope, how astronomical telescopes can work and how magnification can produce, that we will see. So our next concept is astronomical telescope. Astronomical telescope. Look at. So next concept we will see astronomical telescope. See. Astronomical telescope. This astronomical telescope again consists of two convex lenses. One we are calling objective and second one we are calling eyepiece. See here. Very simple here. How this astronomical telescopes can work and how to take magnification power produced by these lenses, that we will see. Here the objective consists of convex lens of a greater curvature, of greater focal length, and eyepiece consists of very smaller focal length of smaller curvature. Initially both lenses when placed coaxially and how the ray diagram can be formed, that we will see. Look at it. Now initially astronomical telescope consists of convergent lenses that we are calling convex lens of greater focal length. This is greater focal length, right? And it consists of smaller convex lens of smaller focal length, that is represented by what value? Eyepiece. So this has focal length of what value? This has focal length of f0 and this is focal length of what value? Fe. We can represent both lenses as L1 and L2. Here what happens? Consider any one object available at infinity point, because telescopes is an optical instrument which see the image of the distance object. Correct or not? Now consider Consider, so both having same common principal axis, I can represent by what value? This is common principal axis, right around this. Now consider the ray of light which is passing from infinity point. So object is available at infinity, the ray of light comes. When ray of light incident, this get refracted. How it is? Now this ray of light can refract like this way. After refraction, how the ray of light can comes again? A ray of light comes like this. Or how to take this ray of light can refract in this way. Look at this ray of light can refract like this. Now consider one more ray of light. The one more ray of light which is passing through optical center such that this ray of light never deviated. Look at me. How to take? Consider one more ray of light that is passing through optical center and this ray of light never deviated. See here, for my convenience I will take one more way. This is nothing but what? Astronomical telescope, two lenses are available. Consider one more ray of light that is incident on the lens. This ray of light refracted. After refraction, how it comes? The ray of light can comes like this. Right. Now consider the one more ray of light that is passing through optical center. This ray of light never deviated. It comes like this. How it is? This ray of light can comes like this. This ray of light is never deviated and passing through optical center. Actually, both ray of light they are meeting at this point. This point I can call A dash and this A dash exactly meeting at this point. This is what principal focus of this one. That is represented by FE. So it is represented by B dash. I mean the intermediate image that is produced exactly at principal focus of the eyepiece because it has smaller focal length. It has a smaller focal length. Then how to take this? I can take a focal length of this object that is represented by F0 and this is focal length of eyepiece represented by FE. After incident at this point, this ray of light can passing through optical center. Shall I represent by this value? Again after refraction, this ray of light can passing like this. So when observer sees, he is the observer. When observer sees the refracted ray, where the refracted ray can meet? The refracted ray they can meet at infinity point. Where the image can occur. Image exactly occur at infinity point. Question is here how to take a linear magnification of this astronomical telescope. See here. This is some angle made. This angle made by the image that is represented by what value? Beta. So it is represented by O dash. Whatever it represent, this is represented by O. Right around this. This is what value? Beta. Beta is angle made by the image. Then what about this? This is alpha. Angle made by what value? Angle made by the object. Alpha is angle made by the object and beta is angle made by the image. In astronomical telescope, how to define magnification? In this case, magnification is ratio of angle made by the image to angle made by the object from any point from the eye. That we are calling magnification. Simply, here magnification I can define. Magnification is equal to angle made by the image at any point from the eye to angle made by the object at any point from the eye. That we are calling linear magnification. So that question is how to take linear magnification. See here, where the intermediate image can observe at this point, that is represented by what value? I value. Right around. Two triangles are looks like. Which one is? O A dash B dash is one triangle. O A dash B dash is one triangle. So I can take one triangle from this triangle. What I taken? I taken O B dash A dash is one triangle. In this triangle, shall I take tan theta? Shall I call this the equation number 1? In this one, shall I call it tan alpha? Tan alpha is equal to what value? Opposite by adjacent. Opposite is what value? A dash B dash. Adjacent to what value? That is O B dash. O B dash. Theta is very smaller. Tan theta nearly equal to theta. So that alpha very smaller. Then I can represent directly alpha. Alpha is equal to what value? A dash B dash whole divided by O B dash. But O B dash is nearly equal to F0. So that, and A B dash is equal to I. Then what is alpha? Alpha is equal to what value? I divided by what value? That is f naught. Let us call this is equation 2. Right? Now, one more triangle looks like O dash, B dash, A dash is one triangle. O dash, B dash, A dash is one triangle. Look at me. From this triangle, I can represent by tan beta. This tan beta is equal to what value? A dash, B dash, whole divided by O dash, B dash. Again, theta is very, very smaller. Tan theta nearly equal to theta. Then, beta is equal to A dash, B dash, whole divided by O dash, B dash. Again, A dash, B dash is nothing but I, image, intermediate image. So, beta is equal to I divided by O dash, B dash. O dash, B dash is equal to what value? Fe, focal length of the eyepiece. So, I can represent by what value? Fe. Now, I can take this is equation number 3 now. Now, very simple. Put equation 3 and equation 2 in equation 1. You can get linear magnification. In what way? Linear magnification m is equal to how much? Linear magnification beta. Beta is equal to what value? I divided by Fe. I divided by Fe. Right. Into alpha. Alpha is what value? Alpha is equal to I divided by F naught. F naught divided by I directly shall I take? F naught divided by I. So I get cancelled. Then what is linear magnification? Linear magnification is equal to F naught divided by Fe. So that. Question is how to increase the linear magnification. If the case F naught is greater than Fe, F naught is greater than Fe, then I can take linear magnification is greater than 1. Very simple. To increase linear magnification, I mean to get the enlarged image, focal length of the objective must be very larger and focal length of the eyepiece must be very smaller. To get enlarged image, the focal length of the objective must be very high and the focal length of the eyepiece must be very smaller. In that cases, we are getting large linear magnification. That is angle made by the image to angle made by the object. This is what astronomical telescope. Then let us see how reflecting telescopes look like. That we'll see. See here. After this, the last concept concerned to reflecting telescope. See here. Last concept of the ray optics is reflecting telescope. Reflecting telescope or Cassegrainian telescope. Cassegrainian telescope. Generally, the reflecting telescope consists of converging mirrors. Converging means it consists of concave mirror and convex mirror. Both mirrors are consist. We know that in case of astronomical telescope, two lenses are required. Those lenses of having a higher focal length and lower focal length. To construct the astronomical telescope, here much more power of the economic condition must be required and it must be very high cost. To reduce the high cost, we should only use the mirrors. Mirrors are the very low cost. Using the mirror, you can get again magnifying power of the distance object. Similarly, reflecting telescopes are the optical instrument which used to see the distance object clearly. I mean, by using the visual angle, we can obtain enlarged image of the object. Here, reflecting telescope, how it consists? That we are calling Cassegrain telescope. Initially, we will see the ray diagram, how the reflecting telescope looks like, and how the ray of light incident, and after reflection, how the image can occur. Look at it. Initially, this is nothing but simple construction of Cassegrain telescope. Simple structure. This is simple structure you can call. So this one consists of a small hole. See here. Look at me, this is simple construction. I can call this concave mirror, and one more is consist of convex mirror. This is convex mirror. Look at me, very simple. The Cassegrain telescope, it consists of two mirrors. One we are calling primary mirror and second one we are calling secondary mirror. So here, this simple construction of Cassegrain telescope, very simple construction we can call like this. So here, very simple. Cassegrain telescope consists of two mirrors. One we are calling primary mirror, that is made up of concave mirror. The concave mirror which provided very small hole at the center. So this is what we are calling, this we are calling eyepiece, and this is as the objective. When the ray of light which is coming from distant object, the ray of light can reflect it from this concave mirror and get incident on the convex mirror, and this convex mirror we are calling secondary mirror. This mirror I can call primary mirror and this we are calling secondary mirror. After incident on the convex mirror, the ray of light which reaches to the eyepiece. How it is? Look at me. Now consider the ray of light which is coming from distant object and get incident like this. After incident, the ray of light must reflect. How it is? This is the ray of light reflect on the secondary mirror. Again secondary mirror reflect the ray of light. How this is? Secondary mirror the reflect the ray of light and it can reach us to the eyepiece. It can reach us to eyepiece. Right around this. Now consider the one more ray of light incident on the primary mirror and get reflect. How it get reflect? It can get reflect like this from the primary mirror. This we are calling primary mirror, this we are calling secondary mirror. Again after reflection from secondary mirror, the ray of light can meet us to the eyepiece, so that image can occur at this point. How it is? The ray of light which is coming from distance object that incident on the primary mirror, this I can call what? This I can call primary mirror. The primary mirror has provided a very small hole at the center. So this is what we are calling secondary mirror. Very simple. The ray of light incident on the primary mirror get reflected on the secondary mirror. Again secondary mirror reflect the ray of light. As a result, all the ray of light can meeting at this point. So I can represent this is nothing but what objective focal length of the eyepiece represented by Fe, and this primary mirror consists of the focal length can be represented by F0. Here also can different. In what we can represent? Magnification is equal to what value? Ratio of focal length of the objective to focal length of the eyepiece. Again, we know relation between the radius of curvature and focal length. What it is? This F0 is equal to what value? R0 divided by 2. So this equation we can modify. In what way? M is equal to what value? R0 divided by 2 into what value? Fe. This is magnification produced by reflecting telescope or Cassegrain telescope. This is simple construction we can take. So this telescope helps to view the image of the moon, sun or other planets. For that purpose, the reflecting telescope can be taken, and it is very low cost because the mirrors are available very cheap. Due to that, the reflecting telescope is convenient to see the distance object. This is concerned to optical instruments that we are calling simple microscope, compound microscope, astronomical telescope and reflecting telescope. Up to here, the ray optics chapter has been over. Thank you.